In this video, I'm going to discuss hydronium and hydroxide in water and how they interact with each other. Acid is a proton donator, raises hydronium, but what is that doing to the hydroxide population? So here, if we have something like HCl, and that is reacting with water to produce H3O plus and Cl minus. Okay, so we've raised the hydronium population. What does that do in water? Well, that hydronium now exists in water, so it can react with other waters, go back to being water itself, and pass on that extra proton in a chemical reaction that probably occurs all the time, but is somewhat meaningless because the reactants and products are the same, so he donated to him, but it's not really noticeable or measurable or observable. But every once in a while, that hydronium might find a hydroxide. If it does, it's likely that hydronium will react with the hydroxide to produce two water molecules. Donate that proton over to him. What that means then is that the hydroxide population is decreased. It's changed back into regular water. So by raising the hydronium population, we naturally decrease the hydroxide population. This works the other way with hydroxide being added into water as well. Imagine, for example, sodium hydroxide being dissolved, producing sodium and hydroxide, and so the hydroxide population has increased. This hydroxide, just like hydronium, might find a water molecule, accept its proton to become water itself, but that just produces another hydroxide. And so this reaction is pretty meaningless. Again, we wouldn't really observe. This probably happens, but we can't really observe it. Alternatively, if that hydroxide finds one of the hydroniums that naturally exists in water, then it can accept its proton and they can both go back to being water molecules. What that means then is that my increase in the hydroxide population will naturally use up some of the hydronium concentration. And so when hydroxide goes up, hydronium goes down. Remember what I said about the ionization of water, autoionization of water. Water itself, with nothing in it, will naturally produce a very small amount of hydronium or hydroxide. So these two, if this happens, then this will be produced about 1 in 10 million of the time. If I go ahead and do something else, like add HCl to this situation, what that's going to do is it's going to increase one of these populations. This reaction happens in both the forward and reverse reaction, so what that's going to do is drive this reaction backwards because I'll have more of this already, and that'll use up my naturally occurring hydroxide. So if I add hydronium through an acid, it uses up or reduces the naturally occurring concentration of hydroxide. Alternatively, if I do something like add a base, like sodium hydroxide, the OH minus that's added uses up the hydronium that would have existed naturally in that water. So all the way back when I defined acids and bases in the first place, I said acids are things that produce hydronium, increase the amount of hydronium in the water, And then I said as a secondary effect, they also reduce the amount of hydroxide. I defined bases as things that raise the amount of hydroxide, and I said as a result they reduce the amount of hydronium. The reason that is because if hydroxide and hydronium find each other, they will naturally turn back into water. So if I create one, I'm going to naturally decrease the population of the other because it will use it up. So that's sort of how hydroxide and hydronium react in water to if one of their populations is increased, it will naturally decrease the population of the other species.